everyone. Welcome to the day 2 of Python series. In today's session, we'll be learning about variables in Python. So let's see the agenda. First, we'll be talking about what are variables in Python. Then we'll be also performing a hands-on on different Python variables. And finally, we'll be talking about Python tokens and the different types of Python tokens. So that's all with the agenda. Let's start the session. But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly. And click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print, print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me. And once you're done with this, press enter. And as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the parentheses there? We'll discuss all of that in a future video. But note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code, and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console. But here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. Press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter. And if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now The main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it B plus C. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took B and added the next string to it. I could even make it a little bigger. B, let me just do it this way. BSDA and CSS, and as you can see that it added it to the it added those two strings together. Now if this was not string, and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. If I have a string called A, B, C, D, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes or 4 bytes depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value, or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age n equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there, so you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start it with anything other than underscore, let's say dollar name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far, and we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is a equals to b equals to c equals to 10. That means set all the variables on the left hand side, which is a, b and c, to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go A equals B equals.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
C equals 15. And if I were to print A, it's 15, B is 15, C is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas. And I tell it, okay, A, comma, B, comma, C. Now I want 10 assigned to A, comma 15 assigned to B, and 20 assigned to C. I press enter, A, B, C. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use A, B, and C, if I were to use B, C, and A, then B will be assigned 10, C will be assigned 15, and A will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python, there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic. Then there's assignment operator. There's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. Things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1, because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is will take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, And just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use and. It will return true if both the statements are true. Similarly, there's an or statement. Or statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16. So what I can do is I can just check s is equal to 15. It returns true. Y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter. And it returns false because one of those conditions is false. So that is the problem because y is equal to 16. Now if I type this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to let's say 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use instead of and I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand. So let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented or any value is represented using binary. So binary is basically just some combination of zeros and one. So when you hear something like integers can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions. To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have this will be 0 since all the 4 numbers are 0. Now what we're doing is I want to check if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so there. So 4, 8, 4, 2, 1. So what happens is if each position, let's say, So these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If let's say this was 1 and this was 1. If this was the binary number that we had, which was 0101. So the way we do this is we take a look at it and we go 2 raised to the power of 4 and you multiply it by the binary digit that's there, which is 0.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3 and the number at the third digit position is 1. Then 2 raised to the power of 2 and the number should be 0 and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and first position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3, this should be 2, should be 1, this should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1. So we multiply it here by 1. Then at the first position is 0, second position it's 1, and the third position is 0. So what ends up happening is we end up creating the sequence in which we go 2 to the power of 3 is 8 multiplied by 0 plus 2 to the power of 2 which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1 which is 2 multiplied by 0 and we go 2 to the power of 0 which is 1 multiplied by 1. And this ends up giving us 0 plus 4 plus 0 plus 1 and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you look at what it means. Now, because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can make numbers, we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space, we can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators. So what they do is they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0. 1 and 0 will return 0. And 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have 2 operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary AND and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be. These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I've given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1, we have come to 4. Right? So that's how this works. So this is what the operator, left shift operator does. It takes the binary format and shifts it by 2. Now, on the other hand, we also have right shift operators. And it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left. There are nothing there, so it's removed and add two zeros at the beginning, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right. And at the very end, let me show you what the not operator does, because this is very something that's not shown very accurately. Not operators turn the number from turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0001, and if I were to use the not operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python and I were to use the ID method and I were to pass it a number 1, you see this long number, this is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to type, try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this, and this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752 and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check one is one, since both of them have the same ID, it will return true. But if I were to check one is one, it will return false. So this is what happens with this. If I were to check one is not string one, then it's true. So that's how it works. And this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it, and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4 and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.